Hello, my name is Robert Smith, and I'm with New River Community College. And today we are looking at greenhouse gases. What species constitute greenhouse gases, and how do we know? So, greenhouse gas is a gas that can not only absorb infrared radiation from the sun, but it also retains that radiation. It retains it and it vibrates in such a way that it's able to hold on to that extra energy, and that vibration results in heat, so we have more heat storage from these molecules. Other molecules will not retain that energy, will just release it, and then that energy will be able to escape Earth's atmosphere, potentially, depending on what other species it encounters on the way out. So essentially, what's happening is that whenever you have a bit of light, photon comes in and hits a molecule of some sort. That molecule can then either release the photon, or that molecule, which we can extrapolate out as being, let's say, bonded with two two molecules bonded together, or two atoms bonded together, can have vibrational modes where they're shifting in and out from each other, or wiggling, or bending. There's many complex types of motion that can be seen in these cases. So we're just going to look at this in a very basic, sort of abstract way. And the main thing to recognize is that you can classify any of the gases that are polyatomic gases and are heteronuclear polyatomic gases as greenhouse gases. So, what does that mean? That means that they can have more than one atom in the gas, but the two atoms have to be different elements. So, as long as we hit those marks, then we know we're okay. So, for CO2, that one should be obvious. It's been in the news for quite a long time. Basically, you have a carbon that's double bonded with two oxygens. And as that light energy comes in, this oxygen shifts back and forth, as does this oxygen shift back and forth. There can also be some bending that occurs, some uh, bending back and forth. But but typically we focus more on the in and out motion that carbon dioxide has. So this oscillation that occurs allows the carbon dioxide to retain that infrared radiation, and so it generate through that vibration, it's generating heat. So essentially, we're retaining the heat that we have on the planet. It's not able to escape into the atmosphere once it's out of the atmosphere into space once it's on our planet. Conversely, with molecular fluorine, it doesn't have that oscillatory vibrational mode. So all it will do is it will allow that energy that comes in will be able to flow back out. So if all that photon experiences is molecular fluorine on the way out from the planet into space, it'll just go right into space, and that'll allow our planet to stay a little cooler. Versus if it hits carbon dioxide will oscillate and hold that heat energy into the planet. So same thing with diatomic nitrogen, molecular nitrogen. So you'd have that, and that's going to allow the radiation to escape into space, so it doesn't retain any. Um, you have water. Water has some very reasonably complex vibrational modes that it has, where hydrogen gets closer and further away from oxygen. There's also bending and twisting, and just different types of vibrational modes that retain that energy. So this one is a yes. This one's a no. This one's a no. And this one's a yes. Methane is also a greenhouse gas. It has it has 5 atoms all told, 4 hydrogens off of the central carbon, and they can all vibrate. So this is a yes. And argon is just by itself, so it's a no. So greenhouse gases are essential for our planet to regulate temperature. But having too many greenhouse gases, too much quantity of greenhouse gases, is not good, simply by virtue of us having all this radiation that's coming in from the sun and then not able to escape at all. It essentially raises the temperature of our planet, and the biological species that live on this planet are attuned to certain temperatures, and many of them cannot migrate. And so their ability to adapt to these changing conditions are somewhat limited. And so that's why this is such an important topic for us. So we need some greenhouse gases. If we had no greenhouse gases, this would be like an ice planet. There wouldn't be anything to keep the radiation from the sun here. So it would be very hot when the sun was on us, and at night it would be frigidly cold. Now we just have it so that there's just a little too much greenhouse gases. So there's this Goldilocks spot, this perfect spot where we can have enough greenhouse gases to not freeze, but not so much that we boil. So we need, that's why people study this topic.